Hi, I am Juan Pedro Dominguez. In this tutorial, I will show you how to download, install, and start using the Neuromorphic Auditory Visualizer tool, shortened as NAVIS. This software presents diverse utilities to develop the first post-processing layer of the information obtained from a neuromorphic auditory sensor. So let's start with the basics. Go to the GitHub page of the project, which is www.github.com/jpdominguez/NAVIS tool. You'll see something like this. Then, navigate to the Releases tab and download the latest release, which can be identified by a green badge with the text Latest Release next to it. Once the file is downloaded, decompress it and double-click on the Obtain folder. The NAVIS_latest build folder contains the NAVIS executable file, navis.x. You can even move this folder to another location and place it wherever you prefer. NAVIS requires Microsoft.NET Framework 4.5 or greater to be executed, so check if it is installed on your computer before double-clicking navis.x. If everything's okay, a window like this should be seen after launching NAVIS. Three main sections can be seen when the main window is opened: the menu, the toolbar, and the cochleograms section. The menu is located at the upper side of the window. It allows the user to access each of the NAVIS functionalities. As can be seen, some of them are disabled until the user loads a file. The toolbar is located at the left side of the application. It has some shortcuts for the most common NAVIS utilities. In the settings, which are deeply explained in the settings section of the NAVIS wiki, the user can select which of them should appear, based on his or her interests. The cochleograms section is the big empty space that can be seen after opening NAVIS. This is used to display the cochleogram of the aedat file after we have loaded it. Before loading our first file, we need to configure the application. We can do this in the Settings window, which can be accessed by clicking on File/Settings or on the button with a gear symbol on the toolbar. You should now be seeing the Settings window. It is divided in different tabs: Main, Tools, PDF, and Toolbar. Here you can change any of the configuration parameters to set up NAVIS the way you want and feel more comfortable with. Each one of these parameters are detailed on the wiki, and the most important ones are explained if you click on the Help button. But for now, we will focus on loading our first file. For that purpose, we only need to modify three values under the Main tab: Channels, to select the number of channels that the cochlea that has been used to capture the audio has; Audio, to select if we are using a mono or a stereo cochlea; and address length, to select the number of bits used for storing the address information of the events fired in the aedat file. If you are using jAER to save the audio information into aedat files, you should select 32 bits in this last field. In this tutorial, we will use one of the aedat files that are provided to the user in the aedat sample files folder of this repository. It is called en un lugar de la mancha.aedat and contains a stream of events that correspond to a young woman reading the first sentence of the famous Spanish novel The Ingenious Gentleman Don Quixote de la Mancha. This file was captured using a 64-channel binaural NAS and jAER. Hence, we will select 64 as channels, stereo as audio, and 32 as address length. After doing these changes, apply them by clicking on the Save Settings as Default button, which is the one with a floppy disk symbol. OK, so now we are ready to load our first file. Close the settings window and click on File/Load aedat or on the first button of the toolbar. Navigate to the folder where it is placed and click on it to load it. After this, the loading process starts. The application gives us some feedback when the file is loaded, and the cochleogram of the file is now displayed in the main window, where events are represented with a dot in a two-dimensional chart that shows address against time in microseconds. This process will take longer depending on several facts: the length of the file, the number of events contained on the file, the size of the dots, which can be changed on the settings, and the number of events that are represented with one dot. As it is right now, the cochleogram only displays one dot per 10 events. Some tweaks can be applied to the cochleogram in the settings. In this case, the information from the left cochlea is represented in blue, and the information from the right one in orange, but this could be changed. We could even deactivate this checkbox to avoid displaying the cochleogram when loading a file, which highly decreases its loading time. Now that the file has been loaded, we can now make use of any of the functionalities that NAVIS provides. The main ones are sonogram, histogram, average activity, disparity between cochlea, manual aedat splitter, and automatic aedat splitter. There are other interesting functionalities that are explained on the wiki, but we will focus on the main ones in this tutorial. Some of these utilities process the audio information using time windows. The width of this window is what we call the integration period, and it can be configured in the Tools tab of the Settings window. Take into account that the smaller this value is, the higher the loading time of these functionalities will be. Each of these tools can be accessed on the Tools menu, or on their corresponding button on the toolbar. The sonogram represents channels against time. The information is processed using time windows with the width of the integration period. The activity rate is displayed using a blue-green-red color scale, where a pure blue means no activity, and a pure red means that that frame and channel are the ones with the highest activity rate on the file. A pure green represents 50%. This is the half between blue and red. The sonogram image can be saved by clicking on this button right here. Also, the value at which the red saturates can be lowered or raised to distinguish specific behaviors that the audio may contain. This button restores this value to the default one. The disparity between both cochlea allows the user to know the difference between the left and the right cochlea, so that the predominant one in a particular time period can be identified. This will be extremely useful in sound localization tasks, because it will give us information about from where the sound is coming. Take into account that this tool will only be accessible when using a stereo aedat file. In this case, blue means no disparity, green means right cochlea predominance, and red means left cochlea predominance. The histogram displays the number of events that have been fired in the file in each of the addresses. Besides letting the user save it as an image or as a CSV file, it can also be normalized, displaying the information in a 0 to 1 range of values. The average activity shows the average number of mega events fired per second in a chart where blue represents the left cochlea and orange the right one. The manual aedat splitter lets the user to manually extract a specific section of the original aedat file and save it as a separate. Clicking on the manual aedat splitter button will open up this little window where the user can write down the initial and ending timestamps of the section that he or she wants to extract. The first and last timestamps can also be set by double-clicking with the left or right mouse buttons respectively on the cochleogram. After the window has been selected, click on the button with the scissors symbol to save it to a new aedat file. If you open it now, you will see that only the information that you selected is now displayed in the cochleogram. NAVIS also implements a splitting function based on the channel's average activity. Two configurable parameters are needed for this purpose. First, the noise threshold, which is the percentage of the number of events that an integration period needs to have in order to be considered as a real sound instead of a noise. And second, the noise tolerance, which is the consecutive integration periods that are needed to be detected above the noise threshold in order to be considered as a real sound instead of a noise. When a period with not enough firing rate is detected, a new split is created if the process passed through noise tolerance consecutive times or more detecting sound. Otherwise, this information will be taken as noise and will be omitted in the results of this function. Clicking on this function will open up a window where these two parameters can be modified. For this file, we will select 20 as noise tolerance and 3 as noise threshold. After clicking on the button with the scissors symbol, the process will start. After it has finished, NAVIS will tell the user how many splits have been generated, allowing to display their cochleogram if the user wants. We have now explained the main NAVIS functionalities. It also has several others, which are described in the wiki, but they will be shown in another tutorial. You are now ready to start using NAVIS. Please don't forget to visit the NAVIS GitHub page for further information on how to use its functionalities, how to configure it, and how to contribute with the project. We hope that you find this tool useful for your research and projects. Thanks!